All right, let's wrap things up with some particle motion. Um, this is going to be a pretty much problem-heavy video because particle motion really just is derivatives and integrals in a little bit of context. So the ideas that we need to have are if position is s of t, velocity is v of t, and acceleration is a of t, then s prime is v, s double prime, that looks weird, I made it into the exponent somehow. Anyway, s double prime is the acceleration, which is also v prime. So the derivative of velocity is acceleration. The second derivative of position is acceleration. We've also got displacement versus total distance traveled. Displacement is the integral from a to b of the velocity function. And then total distance traveled, you just slap some absolute value bars on that velocity function. And that'll give you your total distance traveled. If you have to do this by hand, then you just find where the velocity function hits 0 and break up the integral based on that. Make every integral positive even if you get a negative value. All right, for time t greater than 0, the velocity of a particle moving along the x-axis is given by v of t equals t minus 5, t minus 2 quantity squared. At what values of t is the acceleration of the particle equal to 0? Okay, I need to find when the acceleration is 0 from the velocity. Means I need to find when the derivative is 0. So I'm going to take the derivative. I've got a function times a function. I'm going to use product rule. Derivative of the first times the second plus the derivative of the second, which is a little bit of chain rule, times the first. Now I'm going to distribute all this. I get t squared minus 4t plus 4 plus, let's see, t squared, 2t squared minus 14t plus 20. That becomes 3t squared minus 18t plus 24, and that's what I need to equal 0. Now factor out a 3, I've got t squared minus 6t plus 8 equals 0. Factor that to t minus 2, t minus 4, and apparently the answer is going to be 2 and 4. So I just had, all I really needed to know was that acceleration is the derivative of velocity. After that, it was just a normal old calculus question. A race car is traveling on a straight track at a velocity of 80 meters per second when the brakes are applied at time t equals 0 seconds. From time t equals 0 to the moment the race car stops, the acceleration of the race car is given by a of t equals negative 6t squared minus t meters per second. During this time period, how far does the race car travel? Okay, so I need to eventually integrate velocity, right? But as of this moment, I don't have a velocity function. So what I need to do is I need to take the antiderivative of acceleration. And that's going to be the antiderivative of negative 6t squared, which would be negative 2t cubed minus t squared over 2 plus c. Well, so that's my velocity function. I just need to find out what c is. So this should be cubed. Well, it does say at t equals 0 seconds the velocity is 80, so that would send the first thing to 0, the second thing to 0, and apparently 80 is equal to c. Let me rewrite that. So c is equal to 80 based on that. So now what I need to do is integrate the velocity function from 0 until the moment the race car stops. When is that? Well, that would mean the velocity is 0. Oh my goodness. So that would mean the velocity is 0. I need to find the value of t that does that. This is a very, very deep question apparently. So what I'm going to do is negative 2t cubed plus t squared over 2 plus 80, because remember we found that c was 80 equals 0. I'm going to go into my calculator, I'm going to graph that and find when that happens. Okay, so from graphing it, which I realized while I was doing that, I wrote this wrong. This should have been minus t squared over 2. From graphing that, I find that t equals 3.33862. So then what I need to do now is I need to integrate from 0 to that time the velocity function that we've got. So I'm just going to write right here, it's 0 to 3.33862. The velocity function, and that ends up giving you 198.766. Looks like that would be B. So this is definitely a deep question. First you had to find the velocity function, then you had to find when the velocity function was 0, then you had to integrate the velocity function from 0 to that time. So there's a lot going on. This is a pretty deep multiple choice question. Honestly, if I saw this question, this would be like coming back to you later if there's time. Because there's a lot going on. It's going to take you a lot of time to get through this kind of a problem. Okay, let's see another one. Particle moves along the x-axis with its position at time t given by x of t equals t minus a t minus b, where a and b are constants and a is not equal b. For which of the following values of t is the particle at rest? Okay, so particle is at rest when the velocity is 0. So I need to find the derivative because velocity is the derivative of position. So v of t, you could either distribute this or you could use product rule. I'm going to use product rule just so we see more practice of it. Derivative of the first is 1 times t minus b, plus the derivative of the second is 1 times t minus a. Okay, now I want this to be 0, right? Because I want it to be at rest. So 0 equals t minus b plus t minus a. So 0 equals 2t minus b minus a. Now I'm solving for t, so if I move the b and the a over, that's going to put me in the right direction. So apparently t is equal to a plus b over 2. Okay. For t greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t equals sine of t minus cosine of t. What is the acceleration of the particle at the point where the velocity is first equal 0? Okay, so I need to find the velocity and set it equal to 0. Whatever t value that is, plug it into the acceleration. So v of t, derivative of sine is cosine. Derivative of negative cosine is positive sine. So I need this to equal 0. So negative cosine of t equals sine of t. Now this is a unit circle idea. The first time that cosine and sine are the same except negative is going to be 3 pi over 4. Okay, so now I need to find the acceleration function and plug that in. The derivative of cosine is negative sine. Derivative of sine is cosine. So then a of 3 pi over 4 is negative sine of 3 pi fourths plus cosine of 3 pi fourths. Well, I'm going to finish that right up here just because I ran out of room. I'll change color so you can see the difference. Negative sine of 3 pi fourths is negative root 2 over 2. And then cosine of 3 pi fourths is also negative root 2 over 2. So that's just negative root 2. So A. I always feel really awkward in these videos. I don't know why I'm saying this. I'm talking to no one. But I always feel awkward after I finish a problem because I can't like see if anybody has questions because you're watching the video. You know, this is awkward. Particle moves along a line so that its acceleration is given by a of t equals bleh. If the particle's velocity at t equals 0 is 5, what is the velocity of the particle at t equals 3? Okay, I need to go from acceleration to velocity. So I'm going to do an integral. Well, the t values that I know about are 0 and 3. Okay, well, that's going to give me the change in velocity. I want the actual velocity. So I need to add the initial condition. Okay, so now I put that in the calculator and I get 11.710. Easy as pie. For 0 less than equal t less than equal 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals cosine of pi 6 t. Particle is at position x equals -2 at time t equals 0. For 0 to t to 12, when is the particle moving to the left? Okay, particle would be moving to the left when the velocity is negative. So first I need to consider when the velocity would be equal to 0. Actually, I don't really like doing it that way. Let's just think about it. On the unit circle, where is cosine negative? Well, in quadrants 2 and 3. So from pi halves to 3 pi halves. So whenever the argument of cosine, which is pi 6t, is between 3 pi halves and pi halves, then this velocity function will be negative. All I got to do is get rid of the pi 6, so I multiply everything by 6 over pi. Okay, over here the pi's cancel, and I'm left with 3 less than equal t less than equal, okay, pi's cancel again. This is 3 times 6 is 18 over 2 is 9. There we go. Particle's moving to the left when t is between 3 and 9. For 0 to 12, a particle moves along the x-axis. Okay, same situation. Write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to t equals 6. Well, remember, that's just the integral of the absolute value of velocity. 0 to 6. That's it. That's all you have to do. It was literally that easy. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Okay, first let's find the acceleration, then we'll deal with the next question. Acceleration at time t. Remember, acceleration is the derivative of velocity, so derivative of cosine is negative sine. Times the derivative of the inside. So that's it. That's the acceleration function. Now it says, is the speed of the particle increasing, decreasing, or neither at time t equals 4? Well, if the speed of the particle is increasing, that means the sign of the velocity and acceleration match. Decreasing if the sign of the velocity and acceleration match. Neither if the acceleration is 0. So what I'm going to do first is check to see if the acceleration is 0, because then I don't have to check the velocity. So a of 4 is negative pi 6th times 4 pi 6 is 2 pi thirds, not times. That was silly. Okay, sine of 2 pi thirds, that's root 3 over 2 times negative pi 6. So negative pi root 3 over 12. Okay, so it's not 0. That means I need to check the velocity. Velocity of 4 is cosine of 2 pi thirds, which is equal to negative 1/2. Okay, so I see the sign of the acceleration and velocity match. That means this particle's speed is increasing. Increasing because a of 4 and v of 4 match sign. That's my justification. Hooray! Okay, last problem. For 0 to 12, a particle moves along the x-axis. The velocity of the particle at time t. Oh, why am I reading this? This is the same thing we keep doing. Find the position of the particle at time t equals 4. Okay, I need to go from velocity to position. Remember, if I integrate velocity, that just gives me displacement, so I have to take the initial condition into account. So I'm going to do negative 2 plus the integral from 0 to 4 of the velocity function. I know what you're thinking. Oh, this is a calculator question. That'll be so easy. It's not. It's not a calculator question. This really just is that annoying. You're going to have to use a u-sub. But the u-sub isn't that bad. It looks way worse than it actually is. So let me zoom in. I'm going to use a u-sub here. My u is going to be pi 6t du is pi sixth. I don't have a pi sixth, so I'm just going to move that over by multiplying both sides by 6 over pi. So I've got 6 over pi du equals dt. So then this becomes negative 2 plus the integral cosine of u times 6 over pi du. Okay, I got to change my bounds now though, right? Because the 0 and the 4 are x values. I'm talking about u's now, or they're t values. So when t is 0, u is, well, it's still 0. I'm just plugging into this right here. Okay, that's still going to be 0. When t is 4, u is 2 pi thirds. So again, just plugging into that u formula. Now I just need to take this negative 2 plus 6 over pi. The antiderivative of cosine is sine. And I'm going from 0 to 2 pi thirds. Sine of 2 pi thirds we know is square root of 3 over 2. And then sine of 0 is 0, so I don't even need to worry about it. And as nasty as it looks, that is in fact my answer. Okay, again, wraps up the AB material, not exhaustive, just went through a lot of things that I think are relevant. So if you've made it through all of this, you've made it through about 120 minutes of calculus, very proud of you. Try and find some stuff that I didn't manage to cover. I think I did a pretty good job at finding a lot of varied problems though. I used a lot of those CED and those 2012 problems that we have released. So I think that we've got a good set under our belts and we've seen a lot of different concepts through these videos. If there's anything else you want to see, of course, ask me in class or email me, something like that. BC material, watch out. I'll be making those tomorrow evening and I'll post those as soon as I can. Good luck on your exam, guys.